is that formula sheet? Maybe I need to add one more formula from there. Now I'm very sure you won't remember that. One of you, can you please take note of this and send me a reminder email? One of you want to take the responsibility? You taking?
Yes.
Send me a reminder. I need to add something to the formula. Because by today, after the end of the class, I will go and update that. And that will be relationship between vapor pressure, PV, and saturation pressure, PG, which is nothing but relative humidity multiplied by saturation pressure. So this is PG is nothing but saturation pressure, and that is partial pressure of vapor, and that's relative humidity. Or vapor pressure, which is that PV in there. To find PV, it's given here. I've added it anyway. So relative humidity times saturation pressure. That's already in there as a version of it, but I will still add as a separate equation. So how will you find saturation pressure? You already know the temperatures. Temperatures are given in the question. Okay. So has everyone got the formula sheet open? Good. So I'll minimize that and go to the question. So that way. Okay, so that's all. Now what else you need is data table, which is, if you go to week 5, everyone go to week 5 lecture recording, and that first table, probability table, that first one there, okay, which has got water properties. Yeah, these. We go to table A4. Okay. Now, in the question, temperature of the room is 25 degrees Celsius. So if you go to 25, we find the P saturation, 3.1698. I'll zoom in. 25 degrees Celsius, 3.1698. So air temperature is 25, corresponding saturation temperature is 3.1698. Relative humidity is given as 75%, 0.75, and that will give you your vapor pressure. Is that clear? Lost? You lost. No? Anyone not clear how what I did? That is relative humidity given in the question, 75%. That is the saturation pressure, and the given temperature of 25 degrees Celsius. So at 25 degrees Celsius, saturation pressure of water is 3.1698. And that gives you our vapor pressure. Once you know the vapor pressure, you can find omega. 0.622 times, what is the equation? P vapor divided by P minus P vapor. Wasn't it? So that's the first bit. We have found the partial pressure, which is given in the equation there. So 0.75 times 3.1698. So that part is done. Then specific humidity. We find specific humidity, which is part B of the question. From there, so that's A. That's B. Is that clear? No? And then enthalpy per unit mass of dry air, assuming 0 degrees Celsius as datum. That's where you might struggle a little bit. Let's finish these two parts, A and B first. And others you can start solving for C. Enthalpy, specific enthalpy will be equal to enthalpy of air plus specific enthalpy of water vapor. And the question is saying in the bracket says assume 0 degrees as datum. We had written that equation as Cp of air times temperature of air. Temperature not in kelvins, in degrees Celsius, because datum is 0. Datum is not absolute 0, it's 0 degrees Celsius. So 25 degrees Celsius there, Cp of air plus, what do we need to find? Is omega we already know from times HFG. Now that HFG at 25 degrees Celsius. Where do you get HFG from? From that table, scrolling, going to the right hand side. At 25 degrees Celsius. HFG at 25. 2441.7. Okay? No, nothing? Okay.
0.62.
Oh, that's the equation. Look at the formula sheet. There is a formula on the formula sheet. Everyone open the formula sheet, please. You have the formula sheet open next to you? Yes, that's right. That's the total pressure. Okay. Yeah, thanks for reminding. What is P in there? That P is 100 kPa. That's the total pressure. And PV is what you get from this part A. Comes out to be 2 point something, right? 2.6 or something. 2.37, okay, 75% of that. And so how much omega do you get? What's the value of omega? And what's the unit? Kilowatt? I'll make you think. I'm not going to give you an answer immediately. Think about it for a minute. Think. What's the unit of omega? chart. Okay. Week 11 lecture notes, refer to week 11 lecture notes and tell me what should be the unit of omega. Wow. I explained it to you in the chart as well. What is meant by that? Don't give me a unit. What's meant by omega? Kg of water or kg of dry air. Dry air, very important, dry. So that's the unit. Kg of water, kg of H2O per kg of dry air. You don't write unit, you lose small amount of mark in assessment. I mean, these small marks then brings you from a high distinction to a credit. Why do you want to lose all these marks? So, you know omega, HFG is from the tables, Cp of air, temperature of air at 25, keep that 25 degrees Celsius. So tell me how much enthalpy you get. Huh? 91? 91.8. No. Can you say it louder? Or maybe I won't get that. What are you? No, I don't get 91.7. No, I get 63. 1.7. I'm getting 63 for some reason. Let's find out. Yeah? Oh, it's the latent heat of vapor at 25 degrees Celsius from that other table, which is that value there. So, oh no, it's G. It's G. Why I have written as G? It should be G. Right. Thank you for correcting that. It should be Hg, not Fg. Is the total thermal energy present in the water vapor. So it should be further right. Should be that. That's why that's more. You're getting 61, not 63. So it should be 2546. So that's 1.005 times 25 plus 0.015 times 2546. Okay. 0.5, approximately 63 kilojoules every kilogram of dry air. Okay. Approximately 63. And then mass of dry air, mass of water vapor in the room. Can you find mass of dry air and mass of water vapor in the room? How would you find? Think about it. How would you go about finding mass of dry air and mass of water vapor? What I will do, I will minimize that. I will show you the steps here, so it's a lot more clearer for you. Okay. That solution is there in week 11. No, week 12 tutorial. The whole solution is there. In the last week's week 12 tutorial. Can you find anyone who has finished part A, B, C, try to find D, which is the mass of dry air and mass of water vapor. Don't just wait for me to solve it. Yeah? What was that? D is for dry air or water vapor? Dry air. What did you do? Close enough, but I can see what mistake you have made. I know, a very small mistake. So what did you do? How did you find? What's the main logic behind it? Okay, room volume you mean? Okay, good. You start with volume of the room. Pressure in the room is how much? And would you use total pressure or partial pressure of air? Someone said partial pressure of air, and that's correct. And you have used total pressure, most likely. That's the only mistake. How would you find partial pressure of air? We have already found partial pressure of water vapor. Partial pressure of air is just total minus the vapor pressure of water vapor. So that's 97. So you would use that PA instead of 100 point or 100. Well, how much was it? 100 kP. Instead of 100, you use 97. And instead of 79, it's 63 or 6. No, sorry, 83 or 84. Something like that. No, you haven't done.